Hey everyone, welcome back to our channel. Today we'll be talking about concurrency and parallelism. We'll start with concurrency. Have you ever wondered how a computer juggles multiple tasks at once? From running a web browser with multiple tabs to handling background tasks like downloading files. This is all possible due to concurrency. Concurrency is the ability to execute multiple tasks in overlapping time periods. It doesn't mean they are running at the exact same moment, but they are making progress together. You can imagine it like working on multiple projects throughout the day. You write an email, then take a call, then return to writing. While you don't do them all at once, you make progress on each. This is concurrency in action. Computers achieve concurrency through two main techniques. First is multithreading, where multiple threads within a program takes turns executing. Second is asynchronous programming, where tasks don't wait for each other to finish before starting the next task. These techniques help speed up performance by ensuring a system isn't idle while waiting for one task to complete. Concurrency is everywhere from web servers which handle multiple user requests at once, databases which process many queries simultaneously, and UI applications which keep the interface responsive while running background tasks. A great example is our web browser. It loads multiple tabs, stream videos, and check for updates all concurrently. You can think concurrency like a chef cooking multiple dishes. They chop vegetables for one dish, then stir a simmering sound, then check the oven. The chef is not cooking everything at once, but they are efficiently switching between tasks to ensure all dishes are ready on time. Now I'll talk about parallelism. Have you ever wondered how computers handle massive workloads efficiently? How do AI models train on millions of data points or video games render complex graphics so smoothly? The answer lies in parallelism. The parallelism is the ability to execute multiple tasks at the exact same time. Unlike concurrency, where tasks make progress together but not necessarily simultaneously, parallelism requires multiple CPU cores or processors to truly run tasks in parallel. You can think of relay race versus a sprint team. In currency, runners take turn passing the baton. In parallelism, multiple runners sprint side by side, each running their own race at the same time. Parallelism is made possible by multi-core processor and distributed computing. Instead of single core handling all tasks, multiple cores work together, splitting tasks into smaller chunks and processing them simultaneously. First, we'll talk about multi-core CPUs. In this, each core processes a separate task at the same time. Second is GPUs, which is designed for parallel processing, handling thousands of operations at once. Then we have clusters and supercomputers, which spread workload across multiple machines for massive computation. Parallelism is essential for performance-heavy tasks like AI and machine learning. Then scientific computing and gaming and graphics also. A great example is a GPU which can process thousands of operations in parallel, making it perfect for gaming, AI, and data processing. You can think parallelism is like a team of chefs in a restaurant. One chef is making pizza, another prepares salad, another is grilling, all cooking at the same time. The more chefs you have, the faster meals get served. Now I'll talk about key differences between concurrency and parallelism. In concurrency, tasks are interleaved, which means that if one task is running, another task have to be stopped. While in parallelism, all tasks can run at the same time, due to which in parallelism it requires multiple cores, but in concurrency, a single core can do all of the tasks one by one. Concurrency is for improving responsiveness in IO-intensive process. That is, if a process is IO-intensive, if more than one process is IO-intensive, then if one process is waiting for input, then other process can run. Hence, it improves responsiveness. While parallelism improves speed, that is, it is better for heavy CPU workload. Example of concurrency is multi-threading in apps, and example of parallelism is GPU processing. So that's all for today. Thank you for watching.